The launch of NOAA's GOES-16 and GOES-17 satellites in 2016 and 2018 forever changed the world of environmental monitoring and hazard detection in the Western Hemisphere. As the first two of the GOES-R series of advanced geostationary satellites, they have already begun providing an unprecedented leap forward in U.S. weather observations. Their advanced instruments are streaming back more detailed views of weather events faster than ever before. Now, that legacy is set to continue with the upcoming launch of GOES-T, which will become GOES-18 once in orbit. The GOES satellites provide imagery of the Earth in extraordinary detail and clarity, providing invaluable information to forecasters, government officials, and emergency managers charged with protecting the life and property of those in harm's way. But GOES-16 and 17 are only the first steps in establishing the United States' next-generation geostationary observing system. This year, NOAA will launch the newest satellite in this system, GOES-T. Join us for a front-row seat to this upcoming launch as we take you inside the world of NOAA's GOES-T. The United States uses two geostationary operational environmental satellites, or GOES, at all times. One is in an east position, which keeps watch over most of North America, including the contiguous United States and Mexico, as well as Central and South America, the Caribbean, and the Atlantic Ocean to the western coast of Africa. The other is in the west position, which monitors the western United States, the Pacific Ocean, Alaska, and Hawaii. These satellites orbit more than 22,000 miles above Earth at speeds equal to the planet's rotation. This precise orbit enables the satellites to remain over a fixed area on Earth's surface and provide continuous coverage of more than half the globe, from the west coast of Africa to New Zealand, and from near the Arctic Circle to the Antarctic Circle. In late 2017, GOES-16 officially took over operational duties in the GOES East position, while NOAA's GOES-17 took over the GOES West position in early 2019. Once GOES-T is in orbit, it will be moved into the GOES West position, and GOES-17 will be placed on standby. Weather is always changing, and the better we can predict what's coming, the better we can prepare. The addition of GOES-T will help improve weather forecasting across the country and will provide critical data for the westernmost United States, including Alaska and Hawaii. These areas are dominated by high-impact weather events, experiencing a nearly year-round fire weather season, extreme fluctuations in precipitation, prolonged heat waves, and dangerous flooding. These events can significantly impact human health, agriculture, water supply, and recreation in the region. Like its sister satellites, GOES-T carries a suite of highly advanced instruments. Its primary instrument, the Advanced Baseline Imager, or ABI, allows us to see Earth's weather, oceans, and environment with 16 different spectral bands. These allow meteorologists and local officials to be able to see severe weather events and hazards, like wildfires and floods, develop across the country in near real time. GOES-T is also equipped with NOAA's revolutionary Geostationary Lightning Mapper, or GLM. The GLM continuously monitors lightning flashes. This data is helping forecasters better predict when a storm is forming, intensifying, and becoming more severe. In today's digital world, space weather is not just science fiction. That's why GOES-T has a suite of instruments that will help monitor space weather. Geomagnetic storms caused by eruptions on the surface of the Sun can cause serious trouble on and around the planet. Strong enough storms can damage satellites and electrical power grids, interrupt radio and satellite communications, cause our GPS navigation to fail, and harm astronauts. NOAA's GOES-T will also lend a helping hand to stranded hikers, sailors, and aviators throughout the highly traversed and often dangerous terrains of the western United States. The satellite is equipped with a special transponder that can detect distress signals emitted from emergency beacons. When a signal is received, GOES-T will send the location of the activated beacon to NOAA, which will notify search and rescue personnel at the U.S. Coast Guard and Air Force. Known as Search and Rescue Satellite-Aided Tracking, or SARSAT, the program has aided in the rescue of well over 48,000 people worldwide, including nearly 10,000 within the United States and its surrounding waters since its start in 1982. Taking GOES-T from its initial concept to launch was a highly coordinated and collaborative effort. Teams of experts from NOAA, NASA, Lockheed Martin, L3 Harris, and United Launch Alliance have worked together for years to design and build these 4 GOES-R series satellites. Once completed, GOES-T was tested and a launch vehicle selected. It was then shipped to NASA's Kennedy Space Center in Florida, where it arrived on November 10, 2021, in preparation for launch. NOAA's GOES-T will be traveling to space aboard a ULA Atlas V 541 expendable launch vehicle, or rocket. The rocket weighs about 1.19 million pounds and is a staggering 196 feet tall. When the terminal countdown hits 0, the Atlas V RD-180 main engine and 4 solid rocket boosters will ignite to generate the 2.25 million pounds of thrust to lift the rocket away from the pad. Shortly after liftoff, Atlas will begin its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 35 seconds. At 48 seconds, the vehicle will experience maximum dynamic pressure. All 4 solid rocket boosters, or SRBs, are jettisoned at 1 minute 50 seconds. Less than 2 seconds later, the payload fairing is jettisoned. Approaching booster engine cutoff, the Atlas V burns propellant at the rate of 1,856 pounds per second, traveling at over 13,340 miles per hour, and will be located 83 miles in altitude and 267 miles downrange. Booster engine cutoff occurs 4 minutes 22 seconds after liftoff. A few seconds after that, the booster stage will be jettisoned. The vehicle now weighs a little more than 5% of what it did at liftoff. 10 seconds after booster separation, the first Centaur main engine start takes place. Cutoff of the Centaur main engine occurs just over 12 minutes after launch. The mission now enters a nearly 10.5-minute coast phase. At 23 minutes 39 seconds, the Centaur main engine is restarted. This burn will last 5.5 minutes. Following the second Centaur main engine cutoff at just after 28 minutes, the mission enters a 3-hour coast phase. Roughly 3.5 hours after liftoff, the Centaur is started for a third and final burn. Then, approximately a minute and a half later, final cutoff of the Centaur main engine occurs. At 3 hours, 32 minutes, and 56 seconds, Centaur will release the GOES-T satellite for NOAA and NASA, and the satellite will fly in space alone for the first time. In the days that follow, GOES-T will undergo a series of maneuvers to bring the satellite into a geostationary orbit. This is scheduled to occur approximately 12 days after launch. Once in stable orbit, GOES-T, now designated GOES-18, will undergo an on-orbit checkout of all of its instruments and systems. NOAA expects GOES-18 to replace GOES-17 as the operational GOES-West satellite in early 2023. Join us March 2022 as we see it off on its mission to improve United States weather forecasting.